Hello everyone. Science Spot is a podcast that shines a spotlight on the latest scientific technology from Japan. Your host is Ren from Science Talk. Today I want to talk about a study published by a joint research group including the University of Tokyo and RIKEN. Their finding challenges our basic understanding of aging and cancer. Could getting gray hair actually be your body's way of preventing cancer? Our hair color is made by pigment stem cells located in the hair follicle. Like all stem cells, their behavior is controlled by signals from their immediate surroundings, known as the niche. The research is focused on how pigment stem cells respond to genotoxic stress damage to their DNA. They discovered that depending on the type of stress, these stem cells choose between two completely antagonistic fates: either depletion, which leads to aging, gray hair, or proliferation. The research team visualized individual pigment stem cells to track their destiny. They identified key differences based on the stress type. When stem cells suffered severe DNA damage, such as DNA double-stranded breaks caused by stress like radiation, they activated a specific aging mechanism called senescence-linked differentiation. This mechanism acted like a quality control system. The damaged stem cells were actively eliminated from the hair follicle. The pigment stem cell pool was depleted, causing gray hair. However, this elimination served a critical purpose. It suppressed the risk of developing melanoma, a type of skin cancer. Your body sacrifices hair color to ensure survival and health. This protective path is mediated by the cancer pathway. What happened when the cells were exposed to common carcinogenic stresses such as UV radiation or chemical agents? In this case, the surrounding niche signals changed. The carcinogenic stress activated the niche factor and arachidonic acid metabolism, which in turn suppressed the protective senescence-linked differentiation program. This failure to eliminate the damaged cells means that the DNA-damaged pigment stem cells remained and were even encouraged to self-renew. This dramatically increased the risk of creating a found clone, the starting point for cancer development. This study clearly shows that the fate of our tissue aging on cancerous transformation is determined by a dynamic and competitive interplay between stem cells and their environment driven by the type of stress. The finding carry a major warning. They suggest that our effort to aggressively reverse graying or stimulate the scalp for anti-aging purposes might suppress this natural protective mechanism, potentially increasing the risk of cancer. The accurate understanding of this balance is essential for developing safe and effective health strategies. I would say aging therapy is very popular, but people don't know the risk to the connection of cancer, so I'm expecting the progress of this research. That's all for today's Science Spot. This podcast is broadcast in both Japanese and English. I'd love for you to listen to the podcast and post your thoughts with #ScienceSpot. Thank you for listening and see you next time.